Hey people, welcome back. And in this session, we will learn about the chi-square analysis or chi-square statistics. So mainly we do the three type of chi-square analysis. One is the goodness of fit. Second is called as in test of independence or test for association. And the third one is the cross tabulation. Goodness of fit we do when your y variable is count, like as you have the defects. And these defects are coming from the, let's say, production line. So either the number of defect what is coming from the each of the production line, are they proportionally same or they are different from each other? Then we do the goodness of fit test. Second, we do the test of independence or test for association when your both the variable either count or categorical, like as number of audits you are doing versus number of defects you are getting, or what type of defect you have. This is when both are the count, when number of audits versus the number of defect both are count, or when both are category, like as type of production you are running, which type of product you are producing and which type of products are rejecting. So ultimately whatever the categorical data you have, it will calculate as in count data and it will do. And cross tabulation we do when both the variables are categorical y and x, and you have the additional one variable which is the layer as well, like as you are looking by the shift wise production and the rejection. So shift will be a layer. The machine which is doing the production is the your x variable, and the type of defect or type of rejection you have, that will be your y variable. In this case, we'll be using the cross tabulation. So I will be explaining you first here in this session about the goodness of fit test, which works on the y variable as in count and x variable as in categorical. Let's say you have the production line. Suppose your production line A, I will say line or machine A, you have the machine B, let's say machine C, or maybe the machine, let's say D, right? And if I just copy paste this data for couple of number of times, maybe total number of data points here. Let me see if that works. Yes, it is working. I just drag it down to X numbers. And this data you have collected for each of the machine. How many total samples I have got? 71. Let me make it 200. At least 25 sample I will have from the each of the machine. So up to 100 we are now here, right? And let's me have some defect. So the number of defects which you have in a process may be starting from minimum 5 and maybe going up to 15. Just random number I am generating. And here is the defect. So now I have the production line A, B, C, D, and I have the defect as well from each of the line. Now I wanted to compare the proportion of each of the machine line A, B, C, D are equally generating the number of defect, or are they different from each other? So when your defect is in the count, Y count, and your X variable is a categorical data, will be performing the goodness of fit test. How to do this? Let us see in the Minitab. So I'll just copy this data, defect and production line in Minitab. No need to worry about the normality of the variances because it's a test page doing on the categorical data. Now I have defect and production line. We'll go to the stat, tables. In table, I will be selecting the test goodness of fit or one variable test. Click on this. Y variable is your observed count, which is in defect. And now you have a categorical names, which is your what? Production line, which is line A, B, C, D. On the equal proportion, no need to worry about anything because all the already the things are already selected what we need to see. Just click on OK, and here are the result. Now question is, how do we interpret to this result? So the interpretation of this result, first you will see the p-value. Very first thing in any of the statistical analysis what we do, we look for the p-value. You can see the p-value here 0.269 greater than 0.05, which means a null hypothesis. Null hypothesis says there is no difference. Where are we looking for the difference? We are looking for the difference in the observed and the expected. So if you see, we have total 989 number of samples for 4 categories. where the line A is around 269 defects you have, line B you have 255 defects, line C you have 231 defect, and line D you have 234 defect, which is the sum of all these defects as per the line, the summary. Total 989 defects you have. Now, if I see, because these are the four category, if I see out of one, each one will be around 25% test proportion. 25% of 989 expected is around 247, actually 269. Here is 247 expected, actually is 255. Here 247 is expected, actually is 231. And here 247 expected, actually is 234. So I'm looking for, is there any statistical difference between the expected and the actual? Yes or no? Answer is no, because the p-value is greater than 0.05. But in case you further wanted to look for the difference, so wherever the contribution to the chi-square value is higher, that means that value is far from the expected. Example, if you look for the line B is 0.24, which is the lowest. So 247 was expected and 255 almost nearby. But the highest value contribution is 1.91. You look at 247 was expected and actually is 269, which means a little higher difference or greater difference. That's the way we can see where we have the differences. You look at the graph, which is just the conversion of the expected versus observed. So here your orange line is representing the expected and blue line is representing the observed. So you can see the bars are almost same, expected versus observed. There is no as such statistical difference. Now, the contribution to the chi-square, if you see from this, line A, C, D, and B, the higher is the number, which is this value. If you see 1.91 is coming from the table, which is 1.91, the first value. Second value is 0.24, which is for line B. And the line B you can see is the smallest one, 0.24. So basis on this, we can decide where we have the maximum difference or the lowest difference. That's what this contribution to the chi-square will be telling you. And this is the way people we interpret the result and we perform the goodness of fit test. Thank you so much, and I will see you in the next session.